In this lecture, we're going to talk about solving problems. Solving problems is one of the most important things in programming. So if your goal is to become a great programmer, you need to learn how to deal with problems effectively. So in this video, I will show you how to think as a developer by solving problems using a simple 4-step framework. And let's use our friend John again. So after some time, John can code now. He is almost job ready at this point, but he still needs to work on his problem-solving skills. And in programming, when we say solving problems, we mean a real problem that needs a real solution. For example, in an array of GPS coordinates, find the 2 closest points. And this problem is not straightforward, right? There are a lot of steps involved in solving this. And so we need a way to effectively solve problems like this one, or even way more complex ones. So problem solving does not mean to fix coding mistakes or bugs, alright? Anyway, whenever John encounters a problem that he needs to solve, he usually just jumps at the problem without much thinking. He also implements his solutions in an unstructured way without much of a logical approach. This makes him stressed out when things don't work right away. Another problem that John has is that he is too proud to research when he doesn't know how to come up with his own solution. So all of this is not effective at all. It makes John waste a lot of time. Now the first fix to this is to always stay calm and slow down and not just jump at a solution without having a plan. Also, when solving problems, you need to be in a mindset of taking a logical and rational approach. After all, programming is just logic, alright? Then, when you are in the right mindset, just use my 4-step framework to solve the problem at hand. And the first step of the framework is to make sure that you 100% understand the problem. Step back and take a high-level look at the big picture. And the most important part of this step is to ask the right questions in order to get a clear picture of the whole problem. And the best way of understanding this is probably to look at an example together here. So let's say you are working at some company on some project, and then your project manager comes and tells you, we need a function that reverses whatever we pass into it. And that's all you know about the problem. But do you understand it 100%? Well, probably not, right? I know that I don't. So let's ask the right questions to get there. First, we can ask, what does whatever actually mean in this context? So what should actually be reversed here? Well, and if we think about it, it only makes sense to reverse strings, numbers, and arrays. Objects don't have a well-defined order, so we can't reverse them. And we're also not going to reverse like undefined or null or a boolean, right? Then, after we have that figured out, we can ask, what should we do if something else is passed in that is not a string, number, or array? How are we going to handle that? It's also relevant to ask, what exactly should be returned from the function? For example, should it always be a string, or should the type be the same as was passed in? Well, in this case, probably we should always just return the exact same type that was passed in. Also, we can start to ask more solution-oriented questions, like how to recognize whether the argument is a number, a string, or an array, or how to actually reverse a number, a string, and an array. So these are just some of the questions that we can ask here. I'm sure there are more, but this should already give us a way more clear picture of this problem. Now, right now, at the beginning of your journey, you will probably not yet know what the right questions actually are. But don't worry, this will come with time and practice, I promise. The next step is probably the most important one, which is the divide and conquer strategy. Divide and conquer means to break up the big problem into as many small problems as possible, because these small problems are then a lot easier to solve. And this also ties in with the previous step, because by dividing the problem into subproblems, you also take the big problem apart until you understand it exactly. So based on the previous step, if we wanted to break down this problem, we could define a couple of subproblems. First, we need to check if the argument is a number, a string, or an array. And this is, in fact, a small subproblem, right? So now we can just solve this one in isolation and then move on. The next subproblem is to implement reversing a number, then implement reversing a string, and then implement reversing an array, so that we are ready to deal whatever is passed into the function. Finally, we then also need, of course, to return the reversed value. So these are our subproblems, and they kind of look like a task list that we now need to go ahead and implement. And this is great, because it makes our work so much easier now. Now, sure, this example is a pretty simple problem, but this strategy works just as well for bigger and way more complex problems. In fact, divide and conquer is an essential method of problem solving that is also used a lot outside of programming. Anyway, with this, we have actually already covered the two most important steps of the framework. But now let's say that we actually do not know how to implement one of these subproblems. Well, in that case, we should not be afraid of doing as much research as we have to. Now, of course, we should always first try to implement a subproblem on our own using our own coding abilities. But if we're constantly hitting a wall and cannot move on, then we should waste no more time and just find out how it works using Google or a questions and answers website like Stack Overflow or the MDN JavaScript documentation. We will see how to use these in the next lecture when we're going to work together on a real problem. And actually, researching is a huge part of a programmer's job, as you will find out very soon. So you really should not be ashamed when you don't know enough to solve a certain problem. That's just completely normal. Now, in this case, some questions that we could Google are how to check if a value is a number or an array or a string in JavaScript. Or we could Google how to reverse a number or a string or an array in JavaScript. Okay? And again, we will do this in the next lecture on a real problem together. Finally, in case we are trying to solve bigger problems, we should put all the previous steps together and write some so-called pseudocode before writing the actual code. And pseudocode is simply an informal description of the actual code that we're going to write. So it's like code for humans to understand, not computers. For our example, the pseudocode might look something like this. So you see, we use some structures of a programming language, but this is clearly not JavaScript, right? And there are no real rules on how to write pseudocode either. You just write so that you understand it yourself or other people on your team. So in this example, we just start by naming the function as reverse, and then we basically pass in a value. Then we say that if the type of the value is not a string and not a number and also not an array, then simply return the value back. And that's because, as we defined previously, we only want this function to work for strings or for numbers or for arrays. And again, you can clearly see that this is not any valid JavaScript at all. But anyway, if the type of the value passed this initial test, then we say if the value is a string, then reverse the string. If the value is a number, then reverse the number. And if the value is an array, then simply reverse the array. And then at the end, we want to return the reversed value. Okay? So this is really more like a list of instructions that we now could go ahead and actually implement using the JavaScript language. Okay, and that's it. That's the 4 steps to solve any problem, no matter how big. And now, before I leave you, a final tip I can give you is to develop a genuine curiosity and passion for understanding how things actually work, not only in programming, but really in the whole world around you. For example, the famous scientist Richard Feynman was repairing radios when he was just a teenager, and Elon Musk made his first computer game when he was 12. And there are many more examples like this, and all of them became geniuses in their fields, in part because of their genuine curiosity on how the world around them works. Alright, and with that being said, let's now go ahead and solve a real problem in the next lecture using this framework that we just learned about. So see you there.